So yes, so today we'll go for what uh, buoyancy and fluidation. Correct. So in this session, just a minute, just give me 1 minute. Yes. So buoyancy and fluidation. So to understand the buoyancy, so that is what when body is immersed in a fluid, fully or partially, it is always subjected to upward force. So whenever we suppose, I will give an example to understand the buoyancy. Suppose some fluid is there. So this is the fluid. Yes, like this one fluid is there. And suppose some body, if I immerse the body in the fluid, partially or fully. So I have taken one example of that, what this body is fully immersed in the fluid, correct? So whenever body is immersed in the fluid, some upward force is acting on the body, correct? Or it is to be lifted. So why it happens actually? So if I consider this body, so obviously the pressure forces are acting on this body. So here you can see that in this direction on this surface you will find the pressure forces will act on the body, correct? In this direction or on this surface also you will find some forces will acting on the body. So these are the forces acting on the body, correct? So if you observe this force at this point, whatever the force is acting here and the force acting at this point, so the magnitude of these two forces will be same, correct? Because we know that how the pressure forces are acting, that is P equals to rho gh, correct? So this pressure is depends upon what, that is what the mass density, and h is what the height from the free surface of the liquid, correct? So here the height is h. So for this point the height h is same here as well as at this point. So therefore obviously pressure forces are acting, same pressure forces are acting at this point. Obviously when I move in downward direction, the pressure force starts to increase. So at this point more pressure force will acting, again here some more pressure force is acting, at this point again some more pressure force is acting, again some more, correct? So the pressure force get increases as we move in the downward direction because h increases. The same thing will happen here also, correct? Like this one here also increases, here also increases. But remember that, that is at this point and at this point the pressure forces will be same because at these 2 points h is same, correct? So due to this scenario you will find that the pressure forces acting along the z direction on this particular object will be balanced, correct? So this force is balanced by this force is balanced by this force, correct, in horizontal direction. But what happens when we consider the vertical direction? When we take the vertical direction, you will find that is what here some force is acting, again here some force is acting, correct? So on this surface the pressure forces are acting. At the same time on the bottom side also pressure forces are acting, but the magnitude of the bottom force is larger than the magnitude of the pressure forces acting on the top surface. So whatever the forces acting on the top surface here you will find, so these forces are very less as compared to these forces, correct? These pressure forces which are acting on the bottom surface, correct? So why it is so? Why the pressure forces acting on the bottom surface are greater than the pressure forces acting on the top surface? Why it is so?
Height increases h.
H, due to H, correct? So here H is more, correct? Because when we want to find out this pressure force, so again we have to take what? We have to calculate first pressure, and the pressure will be what? Rho gh. So H is more at this bottom surface than the top surface. So obviously, at the bottom surface, the pressure force acting is more than the pressure force acting on the top surface. Correct? Yes. So what happens? So when I want to calculate the net force acting in vertical direction, correct? Some force is acting on the top surface and some amount of force is acting on the bottom surface. So the net force acting on this object will be what? In the upward direction. Suppose this is 10 Newton. Just imagine. Correct. And suppose this is what? 15 Newton. So net force acting on this object will be what? 5 Newton, and which is acting in the upward direction. Yes. So your body is immersed in the fluid, fully or partially, always it is subjected to what? Upward force due to this imbalance of forces on the top surface and the bottom surface. And the tendency for a body to be lifted up when it is immersed in a fluid is known as what? Buoyancy. So whatever the upward force, net upward force acting on the body, that body or that object tends to move in upward direction. It is to be lifted up, and that tendency of the body is nothing but what? Buoyancy. So I will write down about the buoyancy here. So that is what? Buoyancy. So buoyancy is nothing but what? Tendency for a body. It is the tendency for a body to be lifted up, to be lifted up when it is immersed in a fluid. Either partially or fully. Yeah. Just I have given example, that is what? It is fully immersed. But either partially or fully, when it is immersed in the fluid, always it tends to move in the upward direction. And that tendency is nothing but what? Buoyancy. Correct. When it is immersed in a fluid. Known as buoyancy. Correct. So this is what the buoyancy. So this tendency. So obviously, why this tendency occur? Because there is imbalance of force on the top surface, less force is acting, and on the bottom surface, more force is acting than what? The top surface. So due to this imbalance of the forces, so obviously the resultant force or the net force is always acting in upward direction. And due to that force which is acting in upward direction, the body always tries to be lifted up, and that tendency of the body is nothing but what? Buoyancy. Correct? Yes. So next is what? Buoyancy force. Correct. So buoyancy force is what? Just I will write down here. The force which tends to lift up the body when it is immersed in the fluid is known as what? Buoyancy force. Correct. So I will write down here buoyancy force. Correct. So why buoyancy occurs? Due to this force. Correct. And that force which lift up the body or which tends to lift up the body when it is immersed in the fluid is known as what? Buoyancy force. So I will write down here, that is what? The force which tends, the force which tends to lift up the body when it is immersed in the fluid, when it is immersed in the fluid, partially or fully. Correct. Partially immerse ho, yeah, fully immerse ho. So whatever the force which tends to lift up the body when it is immersed in the fluid, known as buoyancy force. As buoyancy force. So the tendency is nothing but what? Buoyancy, and the force which tends to lift up the body when it is immersed in the fluid is nothing but what? The buoyancy. The buoyancy force. Correct. So this is all about what? The buoyancy and buoyancy force. So is it clear? So is it clear?
Yes, sir.
Yes, correct. So buoyancy and buoyancy force. Correct. Next, and the important thing is what? The center of buoyancy. So we'll go for the center of buoyancy now. Okay. So I will go for the center of buoyancy. Correct. So center of buoyancy. So what is center of buoyancy? What is center
The
of
point at
buoyancy?
which buoyant force is acting.
Okay. The point at which buoyant force is acting. Correct. So that is fine. So the point of application of buoyant force is nothing but what? Center of buoyancy. Correct. The point of application, the point of application of buoyant force, buoyant force is nothing but center of buoyancy. Now the question is what? How to identify or how to find the center of buoyancy is nothing but center of buoyancy. Yes. So suppose again fluid is there and a body is partially immersed. Suppose the body is partially immersed in the fluid like this one. Correct. So how to find out the center of buoyancy? Where exactly it get located? Yes, center of buoyancy means what? The point of application of buoyant force is nothing but what? Center of buoyancy. जिस पॉइंट के ऊपर buoyant force act होगा, so that point is nothing but what? Center of buoyancy. So now the question is what? How to locate the center of buoyancy? Yes, anyone please? How to locate the center of buoyancy? So somewhere here, center of gravity is there. Correct? If plane is
Sir,
there,
it is
so obviously
always below CG.
it is always below CG. Why it is always below CG? And where exactly it is? So obviously it is always, suppose it is below CG. So where exactly it is? How to define the position of the center of buoyancy? How to define the center of buoyancy? Okay, so remember that center of buoyancy is nothing but what? Center of gravity or CG of submerged portion of the body. Getting my point? So this is what the fluid actually. This is fluid. Correct. I will show you this fluid. So it will be very clear. So this is the fluid and here body is what immersed in the fluid. Somewhere here you will find the CG. Correct. Now I want to find out what the center of buoyancy. So remember that center of buoyancy is the CG of submerged body. So this is the submerged portion. So I will show you with the red color. So you will find. So this is what the submerged portion of the body and CG of this portion is nothing but what? Center of buoyancy. So obviously, कहाँ पे आएगा center of buoyancy? So it's below CG. So somewhere here you will find the B because this is what? This is the center of gravity of this submerged portion. And CG of submerged portion is nothing but what? Center of buoyancy. Is it clear about the location of center of buoyancy? Yes, please.
Yes, sir.
Is it
Clear,
clear?
clear.
One more thing, suppose, so this is the water, this is the free surface of the water, correct, liquid. This is the free surface of the liquid. I will show you more, just a minute. Wait, suppose this is the free surface of the liquid, and suppose now the body is like this one. It is fully immersed in the fluid. The body is now fully immersed in the fluid. So now just tell me what about the CG and the center of buoyancy? Where exactly the CG? CG obviously somewhere here CG you will find. Correct. That is the center of the body. What about now the center of buoyancy? So what is the location of center of buoyancy now? Yes, please.
They coincides.
Yes. Can you repeat, please?
Sir, they coincides with each other.
Yes, obviously. What I told you actually, this center of buoyancy is the CG of submerged portion of the body. Here, the body. So this is what again I will show you with the red color. So this is the submerged portion. Correct? Because it is fully immersed. So this is what the submerged portion of the body. Correct? And the CG of submerged portion of the body is nothing but what? Center of buoyancy. The CG of the submerged portion is what the same. So it will coincide with this one. So at the same point, you will find CG and the center of buoyancy. Correct? Yes, is it clear? So this is about what the center of buoyancy. Center of buoyancy means what? The point of application of buoyant force is nothing but what? Center of buoyancy. And the second thing, so how to define the location of the center of buoyancy, and the location of the center of buoyancy is what? CG of the submerged portion of the body. Remember that. CG of submerged portion of the body. So one more example I am going to give you so that you will get the clear idea about this one. That is what? So this is the free surface of the liquid, correct? And suppose the body is like this one. Yes. So obviously CG will be somewhere here, correct? Now just find out the submerged portion. So I will show it again what the red color. So this is what? The submerged portion, and CG of submerged portion is nothing but what? Center of buoyancy, or that is the location of center of buoyancy. So the CG of this red color portion, that is nothing but what? Submerged portion. Correct. So here you will find center of buoyancy. I will representing it as what? B. Correct. So this is what the center of buoyancy. Getting my point? Is it clear to all? Yes, is it clear?
Yes, sir. Yes, sir.
Oh, sir, clear.
So this is what the center of buoyancy. One more thing I want to tell you here. So we are our focus is here on what is buoyant force. Correct. So whenever we want to find out the buoyant force, or whenever we want to study the buoyant force, so first we have to define that force. So define the force means what? We have to define the location of the force, the point of application of the force. So we have seen center of buoyancy is nothing but what? Point of application of the force. Correct? So that we have seen. Next thing is what? We have to define the magnitude of the force also. Correct. So how much force exactly acting, the magnitude of the force, so that we have to understand. So this is what? This is where already seen the center of buoyancy, that is nothing but what? The location of the buoyant force. So this gives the location of the buoyant force. And third important thing that we require, that is what? The direction of the force. So remember that buoyant force always acts in upward direction. Always acts in upward direction. Correct. So whenever we want to know about the force, we should know about three things. That is what? Magnitude of the force. First thing. Second thing, direction of the force. Correct. And third thing is what? Point of application. Where exactly the force is acting. The point at which the force is acting. So we should know about that point. So whenever we know about the magnitude, direction, and point of application, in that case only we can say that we know about the force. So this is the complete, it gives complete information about the force. Correct. So till now what we have seen, so we know about what? So direction of the force. So obviously here buoyant force is acting in upward direction. So we know about the direction. It is always in upward direction. Point of application. So point of application is what, where exactly this buoyant force is acting. So we have seen about this, what the center of buoyancy, and I have already told you that the CG of submerged portion of the body is nothing but what, center of buoyancy. So the point of application is what? The CG of submerged portion. So we know about the point of application, we know about the direction. Now we will go for what, the magnitude of the force, how much amount of force is acting on the body in upward direction when it is immersed in the fluid. So that now we want to find out. Correct. So that is nothing but what, magnitude. Yes. So we'll go for the magnitude. So next is what, we want to find out the magnitude, and Archimedes principle gives the clear idea about the magnitude of the buoyancy force. So how much force is acting on the body. So we'll go for what, the Archimedes principle. Correct. So I will go for what, the next file, new. Yes. So we'll go for what, Archimedes principle. Just a minute. Yes. So we will go for what, the Archimedes principle. Archimedes principle. So, according to Archimedes, actually it defines the buoyant force and magnitude of the buoyant force. Remember that. Correct. So, according to the Archimedes, when body is immersed in a fluid, when body is immersed in a fluid, fully or partially, it's lifted up by a force of the buoyant force, and which is equals to, fully or partially, it's lifted up by a buoyant force, which is equal to, so how much force is acting on that body when it is immersed in the fluid fully or partially, and which is equal to weight of the fluid displaced by the body. Weight of the fluid displaced by the body. Correct. So it defines, Archimedes, according to the Archimedes principle, whenever body is immersed in the fluid fully or partially, it's lifted up by the buoyant force. So already we have seen that why buoyant force is acting. So obviously there is imbalance between the forces on the top surface and the bottom surface, and due to that, the net force is acting on that body is what, the upward force, and that is nothing but what, the buoyant force. So whenever body is immersed in the fluid fully or partially, always it is lifted by a buoyant force, and that buoyant force is equals to weight of the fluid displaced by the body. So whatever the fluid displaced by the body, when we immerse in the fluid, the weight of that fluid is nothing but what, buoyant force. Correct. So I will give you just one example, that is what, some container is there. So I will give yes. So suppose this is the container. Correct. And for just for the understanding purpose, suppose I put here another container. Correct. And suppose here it is filled with some fluid. Water is there, suppose. Imagine that it is filled with the fluid. So whenever I immersed somebody in this fluid, correct? So what happened? So volume, some volume is occupied with this body, and the volume and the same, whatever the volume occupied by the body, the same volume of this fluid get displaced, and here it get collected in this tank. Correct? So it will get displaced. So this much amount of volume is immersed in the fluid, correct? And obviously the same amount of volume get displaced, and suppose the same volume of that fluid I have collected here in this another tank, correct? And weight of this fluid is nothing but what? Obviously the weight is nothing but what? Weight is gravitational force. It is force. Weight is force actually. So weight of this fluid, when we measure the weight of this fluid, so that weight is nothing but what? The buoyant force. Correct? So buoyant force is always equals to weight of the fluid displaced by the body. Correct? And when it get immersed more and more, suppose again it moves in the downward direction, so more volume get displaced, and we will get more weight, means what? Buoyant force also increases. Correct? Suppose it is immersed up to this position, again it is immersed more. So what happened? This much amount of volume is immersed in the fluid. So this much amount of volume get displaced and collected in the tank. That means what? More fluid is collected in the tank, and weight of this fluid is obviously again it increases. Initially volume is this one. This much volume was there, but now the volume is this much. Correct. So that means what? Volume of the displaced fluid also increases, weight increases, and buoyant force also increases. So remember that buoyant force is depends upon what? How much volume is immersed in the fluid. Correct? Yes. So I can write down here. So buoyant force is equals to. So here I will write down. Buoyant force is equals to. So how to find out the buoyant force? Correct. So weight of this one, weight of the fluid, correct, which is displaced by the body. But how much weight get displaced? So how much volume get displaced of this fluid? The volume of the body which get immersed in the fluid. Correct. So here, so whenever we want to find out the weight of the fluid, so always we have to think about what? Weight density. So here I will write down weight density. So weight density. So what is the unit of weight density? Newton per meter cube. Correct. So weight density of this fluid into volume displaced by body. Correct. So into volume. What is the unit of volume? Meter cube. So this one get cancelled. You will get buoyant force. So how much volume displaced by the body? How much is the volume displaced by the body? Weight density. Suppose water is there. So obviously weight density of the water is 1000. 9810 Newton per meter cube. Sorry, 9810 Newton per meter cube. We know about the weight density. So how to take the volume? How to measure the volume of the fluid displaced by the body? How to measure this volume, please? Have you got my question?
सर क्वेश्चन रिपीट कर.
Yes, volume displaced by the body. So here what we want, volume of the fluid which get displaced. So how to measure this volume or how to find out this volume? This is very important formula. From the gate point of view, you should understand this formula. If you understand this formula, you can solve the problems regarding this one. So weight density, it is defined for the particular fluid, correct? Volume of the fluid displaced by the body. So how to measure volume of the fluid displaced by the body? That is my question. Yes. Have you understood the question? So how to find out this volume of a fluid displaced by the body? Because I want to find out the buoyant force. So buoyant force equals to weight density into volume. That is volume of the fluid displaced by the body. Weight density is given, already know, correct? So how to find out this volume of the fluid displaced by the body? Is it clear now about my question?
हो सर क्लियर है.
Yes. So how to find out? So remember that. Suppose I know this one. This suppose this is the block, correct? I know the dimension of this block, correct? So remember that whatever the volume of this body is immersed in the fluid, that same amount of volume get displaced. Getting my point? So this much amount of volume is immersed in the fluid of that body, correct? So same amount of volume of the fluid get displaced. So just focus on this body. That is what, suppose the body is fully immersed. Imagine that the body is fully immersed, correct? And volume of the body is suppose 1 meter cube. Just imagine this one. Just I am taking one example. So how much is the volume of the fluid displaced by the body if it is fully immersed? This body, this is the fluid. I have immersed this body in this fluid. Correct. So now my question is what? The volume of the body is 1 meter cube and it is fully immersed. Correct. So how much volume of the fluid get displaced due to this body? That is my question. How much volume of the fluid get displaced due to 1 meter cube block
Sir, it should
and it
be
is
1 meter
fully
cube.
uh,
1 meter cube, sir.
obviously it is 1 meter cube. So what I am saying, whatever the part of the body is immersed in the fluid, volume of that part is always equals to volume of which portion which is submerged in the fluid. This volume is always equals to volume of fluid displaced by the body. Getting my point? Now is it clear? So here obviously you can see here it is fully immersed and we know that 1 meter cube is the volume of this body. So obviously volume displaced by the body, volume of the fluid displaced by the body will be what? 1 meter cube. Or else I am going to give another example so that you will again understand. That is what? Suppose this is the body and 30% portion of this body is immersed in the fluid. Correct, 30% portion. And suppose 1 meter cube is the volume of this body. So now just tell me how much volume of the fluid get displaced by this body. Total volume of the body is 1 meter cube and 30% portion of this body is immersed in the fluid. So now my question is, how much is the volume of the fluid displaced by body? So
So 0.3 meter cube.
yes, volume of the fluid displaced by body is equals to how much? So obviously 30% of the body portion is submerged in the body. So that means what? 30% volume. Total volume is 1 meter cube. So volume of the submerged portion will be what? Zero point 0.3. So zero point 0.3 meter cube body is, or volume of the body is immersed in the fluid, and same amount of volume get displaced by the body. So therefore the answer will be what? 0.3 meter. I think now this one is clear. Correct. So whenever we want to find out the buoyant force, so we have to use this formula. That is what? Weight density of the fluid into volume of the fluid displaced by the body. And how much volume of the fluid get displaced? It depends upon what? How much portion or how much volume of the body is immersed in the fluid. Correct. So that is how you can find out the buoyant force. So is it clear about the Archimedes principle and the buoyant force?
Yes, sir. Clear.
Is it clear? Yes. Is it clear?
Oh, sir. Clear.
Yes, actually.
Okay. Okay. So this is about what? The Archimedes principle and the magnitude of the buoyant force. So here we can find out the magnitude of the buoyant force. So buoyant force equals to weight density into volume displaced by the body. Correct. So now we know about all parameters, all the things which are required to define the force. That all the things we know now. That is what? Magnitude of the buoyancy force. That's we know. That is what we can calculate that magnitude by using this formula. Direction is always upward direction, and the location of the buoyant force is what? That is what? What is the location of buoyant force at the point of application of buoyant force? So that is what? CG of submerged portion of the body. Correct. So that is the location of buoyant force or the point of application of the buoyant force. Correct. So next point is what? The principle of fluidation. So I will go for the next point. Principle of fluidation. This is also very important. Huh? Sometimes they will ask for 1 mark uh, about the principle of fluidation. Correct. In the gate examination. So it's very important. Principle of fluidation. Principle of fluidation. Yes. So suppose this is the free surface of the liquid, correct? And now I am immersing some body in this fluid. I have started this process of immersion of the body. So initially, suppose this body get immersed like this one, or this much portion is only get immersed. So just I am taking one example to understand the principle of fluidation. Uh, so this is one example, correct? And suppose this is what very slow process. Initially, this portion get immersed and slowly the again it moving in the downward direction. I have stopped at this position, suppose. Correct. I have hold this body. This much amount of portion get immersed and I hold this body. Correct. So somewhere here you will find CG is there and weight of the body is acting in downward direction at this point. Correct. This is CG. I will be representing it as what? G. Correct. And somewhere here, correct, because we know that center of buoyancy is what? The center of gravity of the submerged portion of the body. So somewhere here you will find what? The center of buoyancy. And here the force is acting in upward direction, that is buoyancy force. Correct. So suppose weight of the body is 20 Newton. Just imagine weight of the body is what? The 20 Newton. And now I am going to calculate the buoyancy force. Correct? Actually, just remember that this body still tends to move in the downward direction. But I have paused the situation. It body is immersed up to this level. That is what this much amount of portion get immersed. I have paused this situation. Correct. When I again play the situation, again the body will move in downward direction. Just actually, I am doing this for the understanding of this principle of fluidation. Correct. So at this position, this is the first position. Correct. So this is the first position. So for the first position, now I want to find out the buoyancy force. So buoyancy force, we know that what is buoyancy force or how to find out the buoyancy force. So that is what the weight density of the fluid into volume of the fluid displaced by the body. So how much volume of the fluid get displaced? So that is equals to volume of, correct, here I will write down weight density into volume of fluid displaced. Correct. So here the buoyancy force equals to weight density, that is we know, correct, into a volume of the fluid displaced. So how much is the volume get displaced? So the volume of the body which is submerged in the fluid. Correct. So this much amount of volume of the fluid get displaced at this position 1. Correct. Suppose I got this number also, and when I calculate this one, suppose this is 10 Newton. So what happened? Now the weight is 20 Newton, and when I calculate when the body gets submerged by this amount, correct, or for the position 1 I consider. So here, if when I calculate the buoyancy force, suppose this is 10 Newton. So what happened? This weight is greater than the buoyancy force. So obviously what happened? The body again starts to move in downward direction. Correct. Again, when it starts to move in downward direction, so again I will take the second position, the same body, the same fluid. Correct. Now, more portion is immersed in the fluid. Correct. In the first situation, only this much amount of volume is immersed in the fluid. Now, the more amount of the same body is immersed in the fluid. Correct. And here the weight, and here somewhere here you will find buoyancy force is acting, FB or F. Correct. Now, what about the buoyancy force? Whether this is greater than 10 Newton or less than 10 Newton or equal to 10 Newton. Weight is remains the same. That is what 20 Newton. Same body, yeah. Just more portion is immersed in this fluid. Correct. So now about what about the buoyancy force? Whether it is equals to 10 Newton, greater than 10 Newton or less than 10 Newton.
Sir, greater than 10.
Greater than 10 Newton. Why? Why it is greater than 10 Newton?
Sir, volume displaced also increases.
Correct. So volume of the fluid displaced by the body increases. So this volume increases means what? Obviously the buoyancy force increases. And suppose this is now 15 Newton. Correct. So what happened again?
It still go downward.
It still move in the downward direction. Correct. So when it starting to float, when exactly it stops to moving in the downward direction, it starts to float. In which situation?
Sir,
When
weight
weight
and
of body.
buoyant force is equal to are same.
Yes, that is what, when the weight of the body becomes equals to what? Buoyancy force. Because when body moves in downward direction, buoyancy force slowly increases. And at some point, you will find that this buoyancy force and the weight of the body becomes same. In that case, body starts to float. So remember that whenever body floating in the fluid, in that case, always weight of the body is equals to the buoyancy force, and that is nothing but what? principle of fluidation. Getting my point? So for the fluidation, for the floating situation, the most important thing is what? Weight of the body is equals to what? The buoyancy force. And that is nothing but what? Principle of fluidation. So I will write down here the principle of fluidation. So that is what? So principle of fluidation, it states that weight of the body, weight of the body floating in a fluid, floating in a fluid is equals to buoyant force, is equal to buoyant force. Correct? So for any floating body, just remember that weight of the floating body or the body floating in a fluid. Correct? So for the floating body, always weight of the body is equals to the buoyant force. For every floating body, it follows that is what? Obviously, this floating means what? There is balance of what? Weight of the body and the buoyant force. Clear? So this is what the principle of fluidation. Fluidation. When body floats, when the weight of the body becomes equals to what? The buoyant force. Clear? So that is what simple principle of fluidation. Yes, is it clear? Yes, okay. So next we will go for what? The meta center and the metacentric height. Correct. So the next point is what? Meta center and the metacentric height. So meta center and metacentric height. Correct. Yes. So first we will try to understand what is meta center, and after that we will go for the metacentric height. Correct. So again, I will take one situation to understand the meta center. That is what? Yes. So here I will show you one situation. So suppose one body is there and which is submerged in the fluid like this one. Correct. It is submerged in the fluid. Correct. So again, we know that here somewhere you will find CG or the center of gravity. So I will show it as what? G. So this is center of gravity of this body, and the center of buoyancy will be what? The center of gravity of submerged portion. So half portion of this body, suppose the half portion of this body is submerged in the fluid. So obviously the CG of half portion of this body is nothing but what? Center of buoyancy. So I will put here somewhere here, that is what, at the center of the submerged portion you will find the center of buoyancy. So here G and here B, that is what? The center of buoyancy. Correct? Suppose this body is displaced by some small amount of force. Very small amount of force is acting on this body and it will get displaced. Correct? So second situation I'm going to show you here. So here again, here the fluid, I'm showing the fluid and just I am applying what? The small amount of force. Correct. So due to the small amount of force, suppose this body get displaced like this one. Correct. So this one get displaced. Correct. Yes. So again, when it get displaced like this one, so we will find somewhere here G is there. Correct. And what about the center of buoyancy? What about the center of buoyancy? Give me just a minute. Just give me 1 minute. Yes. So what about the center of buoyancy?
Sir, position displaced.
Displaced, because center of buoyancy is what? CG of submerged portion. Now submerged portion is this one. Correct. So it will get displaced and it will acquire the new position. So this is what the B1. I will name it as what B1. And B is what the old center of gravity. I will show you. Correct? Yes. So now what is meta center? So what I'm going to do here, so that is what I will draw one line which joins this old center of buoyancy and center of gravity. So I will join this line. Correct? And so this is the axis which is passing through what? Center of gravity and this old center of buoyancy. Same line here also you will find. Correct. So this line I have drawn here, and another line I am going to draw here, which is the vertical line passing through the new center of buoyancy, which is passing through the new center of buoyancy. And the point of intersection between these two lines is nothing but what? Meta center. Correct. So meta center is the point of intersection between the axis which is passing through this old center of buoyancy, that is what the buoyancy before the displacement, and the center of gravity. Correct. And the vertical line which is passing through the new center of buoyancy after displacement. So that point of intersection is nothing but what? Meta center. Correct. So whenever body get displaced or slightly get displaced, so you will get the new center of buoyancy, and the vertical line, the point of intersection between the vertical line passing through the new center of buoyancy and the axis which is the passing through this is center of old center of buoyancy, that is before displacement, and the center of gravity is nothing but what? The meta center. So that is the meta center. That is how you can locate the meta center, and how we can define this meta center. So is the point about which body is oscillating. Correct. When we give the slight displacement, it get displaced again, it will regain its original position, again get displaced. So that means what? This body is oscillating, and it is considering that this body is oscillating about some point, and that point about which this floating body is oscillating is known as what? The meta center. So I can write down here is the point about which body is oscillating, about which body is oscillating is nothing but what? Obviously it is a partial or fully immersed body. Correct. Oscillating is known as a meta center. Correct. And now to locate that one, that is what? Vertical line through the new center of buoyancy after displacement, and the axis passing through old center of buoyancy before displacement, and the center of gravity. So the point of intersection between these two lines is nothing but what? Metacenter. Correct? And the distance between this G and the M is nothing but what? Metacentric height. The distance between the G and M is nothing but what? Metacentric height. So this is what the metacentric height, and this is what the metacenter. So is it? Are you clear about this metacenter and the metacentric height? Is it clear? So that we will move towards the next and the last point. That is what? Stability of submerged floating bodies. Is it clear? Yes. Okay. So we'll move towards what the next point, and that is nothing but what? Stability of the floating body, submerged and the floating bodies. We can say that. Correct. So stability of, this is the last point. Stability of submerged or the floating bodies. Correct. Yes. So the one situation I'm going to so actually, so first we need to define what the stability of the floating body. Just a minute. Yes. So stability of the floating bodies. So first we need to understand what is stability. So stability means what? Tendency of a submerged or the floating body to return to its original position after it has been displaced. So I will just write down about the stability here so that we will understand what is stability. And after that, we will go for what? The three stability conditions which are very important. Correct. So first we will try to understand stability. Stability is the tendency of submerged or floating body to return to its original position, to its original position after it has been displaced, after it has been displaced slightly. So whenever floating body, you can take the example of what the ship, when it is floating, correct, in the water, so it will get displaced due to small forces acted by what? The tidal waves or the force by the air, correct? So it will get displaced. So what is stability? If it tends to regain its original position, or it will try to return to its original position, or if it returns to its original position, so the tendency of the body to return to its original position after it has been displaced due to small force is nothing but what? Stability of the floating body. So there are three conditions are there to define the stability of the floating body. So the first condition is what? Stable equilibrium condition. Stable equilibrium condition. Second condition is what? Unstable equilibrium condition. Unstable equilibrium condition. And the third condition will be what? The neutral equilibrium condition. Neutral equilibrium condition. So these are three conditions, or the three stability conditions are there, so that we have to study. So in which situation, or in which case we will get the stable equilibrium condition, in which conditions we will get the unstable equilibrium, and in which situation we will get the neutral equilibrium condition. So that we have to understand here, correct? So first we will go for what? The stable equilibrium condition. So suppose here I am going to give again one example to understand this one. So suppose this is the body, correct? And suppose this is immersed in the fluid, correct? It is immersed in the fluid, like this one. This is immersed in the fluid, and some small amount of force or the slight displacement is there due to the force, suppose, and suppose it will get displaced. Suppose it will get displaced like this one. Yes, so here you will find somewhere here the center of gravity G, somewhere here you will find center of buoyancy. Correct. Same thing is here again. This is what? The G and old center of, that is what this B I will shifted here. Correct. And due to the displacement, just I have write down this B here, huh? Nothing more than that. Actually, this B gets shifted because now the submerged portion is this one, and suppose this B gets shifted to this position, and suppose this is B1. Correct? So, how to define the meta center? So, obviously, the line which is passing through this one, and the vertical line which is passing through this one. Correct? So, this is meta center. Now here there are two forces acting on this one. That is what? At the G, weight is acting, correct? And at this B1, buoyancy force is acting. Now if you observe these two forces, remember that this is floating now. So that means what? Weight and FB are same, correct? So these two forces are now parallel. One is weight and another is what? FB. These two forces are parallel and equal, so it forms one couple, correct? And always we know that always couple tends to rotate that body, correct? And due to this force, this body will tend to rotate in anti-clockwise direction due to these two forces. If you observe this one, so it will try to rotate in anti-clockwise direction. So that means what? It will try to rotate in this direction, and that means what? It is trying to regain its or return to its original position, and this one is nothing but what? Stable equilibrium condition. This is what? The stable equilibrium condition. And when we observe this one, so for this stable equilibrium condition, so this is stable equilibrium condition, and here you will find the b yum. So if I take this b and this yum, so here in this case b yum is greater than bg. So in stable equilibrium condition, Bm is greater than Bg. So this is the desired equilibrium condition. This condition we want. That is what, whenever floating body gets slightly displaced, always it should try to return to its original position, and that is nothing but what? Stable equilibrium condition. Is it clear about the stable equilibrium condition?
Yes, sir.
Yes, correct. So next condition is what? Unstable equilibrium condition. So again, I am to give one example. That is what? Again, the same body is here, and suppose again it is immersed in the fluid, and suppose again it get displaced. Again, suppose it get displaced. Correct. So suppose it get displaced like this one. Yes. So again it get displaced, suppose. So here somewhere you will find G, here somewhere B, correct? So again I will draw the same, that is what, here somewhere G, somewhere here B, and suppose the new center of gravity is shifted to this position, that is what, B1, correct? So obviously what happened here, you will find this line axis, and the vertical line which is passing through this one is like this, correct? So here weight is acting, and here buoyancy force is, Fp is acting. So here in this case you will find weight is like this one, correct? And buoyancy force is like this one. Here the buoyancy force on the left side, on the right hand side weight. But here on the left side weight is there and buoyancy force on the right hand side. And again it forms couple, and it will rotate the body in this direction. So again, if it will try to rotate the body in this direction. So that means what? The body becomes more and more unstable, and that is nothing but what? Unstable equilibrium condition. Correct? And in this case, so obviously this point is what? Yum. In this case, B yum is less than Bg. In this case, Bm is greater than Bg, and in this case, Bm is less than Bg. Because these two forces forms couple such that body tends to rotate in clockwise direction. So that means what? It becomes more and more unstable. It does not try to return to its original position. Therefore, this situation or this condition is nothing but what? Stable equilibrium condition. Clear? So we have seen two conditions: stable equilibrium condition and unstable equilibrium condition. Is it clear?
Yes, sir, clear.
Is it clear about the stable equilibrium condition and unstable equilibrium condition? Yes. Okay. So next one is what? The neutral equilibrium condition. So what is neutral equilibrium condition? So what will happen about the position of M? Or my question is what? What about the BM and BG in case of neutral equilibrium condition? In stable equilibrium condition, M is above G. Correct. In unstable equilibrium condition, M is below G. So what about the neutral equilibrium condition? Or what will exactly happen in neutral equilibrium condition, or what is the position of M with respect to G? In stable equilibrium condition, M is above G. In unstable equilibrium condition, M is below G. And what about the neutral equilibrium condition? So what will be the position of M? Yes, anyone? what will be the position of M with respect to G?
Sir, they coincides with each other.
Yes, obviously they will coincide with each other. Correct. So I will explain that point also. So suppose body is like this one, correct? And when it slightly get displaced, so somewhere here G is there, somewhere here B is there, correct? So here also this is what B, this is what G, and somewhere here suppose a new center of buoyancy B1. So what happened? So obviously this is the axis passing through B and G, and the vertical line passing through B1. Correct. So here weight and here FB is acting. There is no formation of couple. So therefore it will acquire one position, and that is nothing but what the neutral position. It does not try to regain its original position or return to its original position, as well as it does not become more unstable. So therefore it is known as what? Neutral equilibrium condition. Neutral equilibrium condition. Correct. Obviously this M coincide with B, sorry, G. This M, sorry, this is B, and here G, that is center of gravity. So M coincide with the center of gravity, and obviously GM, that is what, sorry, Bm is equals to Gm. So this is what the neutral equilibrium condition. Correct. So this is what, this is the end of our session. So